Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at home run options in Design Master Electrical for AutoCAD. If you are attending the training live, you can ask questions in the chat box. If you are watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. Let's go ahead and get started. We're looking at home run options in Design Master Electrical. You can get to your options by going to Customization, Options, Edit Project List. That'll modify the options for your current project. Edit Standards List does it for future projects. It's on the pull down, which is an easy way to find all your customization stuff because it's nicely organized there. It is also available on the ribbons. We have the options command here for projects and then standards. Sorry, that's actually the wrong software. It's here. Options, it's still in the top left for the projects, and for master, it's here. For the purposes of this demonstration, I'm going to be using my toolbar just because it's handy there, and then we can be working with the other commands more easily as we make our changes, so I'm not flipping between ribbons all the time. So I'm going to run the options command. And we are now in the home run and loops section. So we're going to be looking at the options listed here. The first option we're looking at is hot or neutral first. And what that's referring to is for your tick marks when we draw them, what the order of the tick marks is, whether the hot tick marks are displayed first or the neutrals are displayed. Currently it's set to hot. If we come down here and take a look, here's a home run that has the tick marks included on it. So you can see we have the hot, which is the short one, and then the neutral, which is the long wire second. I'm going to create a 3-pole device just so that we can see a little bit more easily what's going on. So there. The 3 hot wires are in front, and then the neutral wire is in the back. If we go to the options, we can change that from hot in front to the neutral first. And if we redraw the home run, it will update with the graphics, neutral wire first, and then the hot wires after it. When you make changes like this, the coordinate might pick them up. You might have to redraw the home runs to get them all to display. Generally, you want to make sure you have these right before you start working on a project because it's not totally optimized for changing these in the middle of a project. So if you do have tick marks you want to adjust, we recommend you do that before you get a whole lot of work done. The next option is the ground location, whether it's at the front or the back of the list of tick marks. Currently it's set to front. I will switch that to back. So you'll see that we've got the ground in what we consider the front or first. So I'll just flip this wire here to the back. So now we've got the neutral wire first, then the hot wires, and then the ground wire in the back. The next option is whether we draw loops between devices on circuits. And when we expand this, there are a lot of options because this is actually like 3 options all combined into one. So you have to kind of read carefully to see what each of these options do. So the first is, do we draw loops? Yes or no? So we've got a bunch of options here for including loops, and then a couple options that don't, and then some that do. So the yes or no is whether we're drawing the loops. Then the next thing that we're looking at is whether we include a circuit callout on the devices. So we can have the option to remove the circuit callout, which is these first 2. We can include the circuit callout with with 2 different options really. One is to include the circuit callout with the panel and the circuit number, if you want to have the full callout listed next to each device, or just the circuit number without the panel. So we have got the option for whether we're drawing loops, yes or no. We've got the option for whether we're including the circuit callout and how that's displayed. And then we have the option for whether we display the callouts for the first 2 on combined home runs, and then where we don't have a circuit callout generally, and then we can whether we display the circuit callouts on a combined home run. And then for all the ones where we display the circuit callouts, whether we display those circuit callouts on switches or not. So these first ones are all without the callouts on the switches, and then these last ones are with the callouts on the switches. So you take all of that up, you kind of mix them up, you do all the combinations, and those are the choices you have. So let's take a look at what each of these do. So our default is to draw the loops, remove the circuit callout, and include the callout on combined home runs. So as an example of that, let's come over here. Let's circuit up a couple of these light fixtures so we have something to work with here. All right, so if we just, with the current setting, if we draw the home run, you'll see that we get the loops, and we don't have any circuit callouts on the devices. If we combine the home run, we put these two circuits together, it will still display the circuit number next to each device and give us the combined home run. And then when we draw the home run for the switch, it's pretty much like this option down here, just displaying the loops with no circuit callouts. Now we can look at the next option in our choice there. So we're going to draw the loop still. We don't want to include the circuit callouts, and we don't want the circuit callouts on combined home runs. So what this will do is for these ones, it'll actually remove these circuit callouts. So if we run the draw home run command, combine this home run, that description is actually more sophisticated than I realized. It's remove callouts when all the circuits from a combined home run are on that device. So it's actually a little bit more sophisticated than what I was showing. Because here, and it makes sense, you want to show where which circuit these light fixtures are on, even though they're combined. What that's actually talking about is when you have, say, a receptacle with multiple loads on it. So I'm going to put in two receptacles here. They both have two circuits. And now we are going to circuit those receptacles. I will put the first load on one circuit, and I'm going to put the second load on another circuit. So those are both connected to two different circuits. And we have two options for how we draw the home runs with this, actually. We can draw the home run, and then it asks which circuit we want to do. I'm going to do circuit 14 to begin. It'll put in circuit 14. And then I can also do circuit 16. I can have separate home runs for them. So you can have separate home runs for the two different circuits. And if we go back to options, I should show you what this looks like with the original option set. So here we want to include all circuit callouts on combined home runs. So now if I draw a home run, I can actually combine that, which makes sense because they're right next to each other. You probably would combine that together. And so we have the home run going to that circuit, and we have this circuit callout saying that both of these devices have both of those circuits, which is more labeling than you need because it's kind of implied they're going to here. They're obviously, if there was no label, you would imply that they're both connected. So what we can do is we can go into the options. If you don't want to include that additional information, change this to the second choice. And now when we redraw that home run, it'll put in just the circuit, the combined home run, but it removes these labels here. And now our next choice is the option to include the panel in the circuit callout and then not have the callouts on the switches. And what this will do is if I draw my home run here for this one, it's actually going to label all of these devices with the circuit that it's on. This one is not because it's connected to this home run. And then we can do the same thing up here on where we've got switches, but it's not labeling the circuit the switch is on. And we can take a look at the next option. And it's include the loops, include the circuit callout, but remove the panel name, and again, remove the callouts from the switches. So if we go down here to this, right now we have the panel L1-7 listed. We run this command, and it lists just circuit 7. Because the L1 hopefully is implied, it's implied here because you're connected to this home run. I'm going to jump over these two and go down to here to show you that we can also include this callout on the switch if you want to. And again, you've got the same option whether you include the panel or not. So I will remove the panel to do just the circuit callout, but do it on the switches. Run that command up here, draw my home run. So now we have the callouts listed on the switches in addition to on the devices. Now we go back to our options. So I don't need to show you that we can do the same thing and it'll show you the panel. That starts to become pretty obvious. You can start to see how that would work out. The final thing here we have is to not draw the loops. So this will remove the loops if you just want to have just the circuit callouts. And so then you have the option, if there's no loops, whether you're doing what style of circuit callout and whether they're on the switches. If it's obvious which panel they're connected to, you would maybe remove the panel so it's less cluttered. Or if you got multiple panels going on, that's where you would want to include the panel name and probably include the callouts on the switches. So I'll do it to include the circuit callout, include the callouts on the switches. Now we draw our home run. We'll get the home run, and it'll just change all the circuit labels for us and draw no loops. Okay, so those are all the options that we have. Various ways to show circuit callouts and loops and not loops. One question you could have is, okay, it's interesting that it does all of that. Why would you ever want to use any of those options? Typically, people either show or not show the loops, and so you're kind of making your choice there. But the circuit callouts, typically, if you're showing loops, you're not also showing circuit callouts. So those are the ones that need a little explaining. Currently, our voltage drop depends on these loops being inserted because we actually trace the path of the loops and we calculate the voltage drop using that to calculate distances. And as you move along, you're going farther, but there's less load. We take all that into account when doing a branch circuit voltage drop. If you don't have the loops, we don't know the path, and so we can't calculate the voltage drop. So if you don't want to show loops, but you want voltage drop, we actually say, okay, you have to still show the loops. So you come back here and you turn your loops back on. But you show all your callouts still because we're eventually going to get the loops to go away. So here you come back and say, okay, I'm going to include my loops, but I also want to include the callouts. So you do something like this. But obviously, we're showing all this, but we just said we don't want to actually show the loops. So we have them there for voltage drop purposes, but we don't want them there for printing purposes. And what you then do is you go into the layers and you set those layers to non-plotting layers, and then they won't show up on your published drawings. So they're there for calculation purposes, but they're not being included in what's being published. So that's a matter of going into your layers settings, finding your various circuit layers. We kind of throw everything together on one layer. We have the home runs and the loops on the same layer by default. So you would need to create a new layer for home runs if you want to show those. Set one to non-plotting, one to plotting. You can do that here. If you don't want it to clutter up your drawing, you might take it from a very bold, like this white is very bold, and it's going to clutter it up as you're working on it. You might change it to a dark gray so it fades into the background. It's there. The software can use it for calculations, but it's not bothering you when you're trying to make sense of your drawings and cluttering everything up. So that's the purpose of that option and why we have all of those different choices. Moving on to our next option, we have the choice for loop to same circuit first on combined home runs. And we have two choices for light fixtures and other devices. We handle that a little bit differently. So the idea here is where you have a combined home run. How do we do our default grouping for our looping? Our software, to the best of its ability, tries to draw its loops nicely. Sometimes you have to go back and fix it. But this gives it a little bit of a hint as to how you want it to draw the loops. And so what this does, as it's currently configured, is that we'll connect all of the lights on the circuit together, and then we will connect those groups. And then on other devices, we'll just connect it to the closest device. So if we go over here and take a look at, say, these receptacles, this is a good example, where with the receptacles, you really want to just have them connect to the closest receptacle, even though we've got these on separate circuits. And so that's what's happened here. So if we redraw this home run, it's not going to change because it's set up properly. Make sure I get all of my circuits in there. So it nicely connects everything for us. I can go back and change that. And so those are other devices, not light fixtures. So I'll change that from no to yes. And now what it's going to do is it's going to take the same circuit, connect them, and then connect those groups together. I'm also going to turn off my circuit callouts because loops and circuit callouts starts to get a little bit messy. It's a combined home run, so it'll still have the callout, but at least we'll get rid of the panel. So now I draw my combined home run again. Select all of my circuits, and it's going to connect the circuits together, and then so obviously this is not ideal for this particular configuration, but this is why we give the option. So we've got circuit 2, it connected those, got circuit 4, we connected those, circuit 6, we connected those, and then once it had all of that, it said, okay, we'll do for circuit 4, we'll connect it here, and for the rest of the stuff, we'll make this connection. So that's what it was doing. It comes into play more for light fixtures, where you might want to make sure that you connect within your circuit first before you connect to other ones. So for an example of that, let's take a look at these light fixtures here. So here it's putting all of these on circuit 7 together first, on circuit 11 together, and circuit 9, and then it connects them all. We can turn it off and just have it connect to the closest item. Yeah, so this is a good example of where you don't want this. So if these are receptacles, you might want to connect them this way, but for light fixtures, particularly if they're actually switched, we connect here, and so we've got circuit 7 split between half of it's over here on the left, going through this light fixture, the other half is here, connecting up here. So that circuit is widely spread across this combined home run. So that's why you can join them first. So that's how you can control the default looping that Design Master gives you. And always, the software is doing its best, but it's not always going to be right. If it's not right, you can try and get it to match it, but if it's just a one-off, it's sometimes simplest to just go in and address it manually. And to do that, you would erase this loop, and then manually put a new loop in, so we connect those. And when you do that, you then need to have the software update those tick marks, because it doesn't know that you made those changes, so you run the draw tick marks command, select your device, and then it updates all the tick marks for you based upon the new loops that you've drawn in. So you can update your loops and then update the tick marks. The next option is the home run wire callouts and tick marks setting. And again, we've got quite a few choices here. The default that the software ships with is that we draw tick marks on home runs for number 12 wire. And if any of the wires are larger than number 12, we give you a full wire callout. So here we've been working entirely with number 12 wire. You can see we've got the tick marks. Here in this mess, we have this piece of equipment with the number 10 wires, so we give you the full wire callout. So then somewhere else on the legend or whatnot, you say, hey, tick marks, number 12s, anything else, we give you the full size. We can adjust that depending on what you like to do with those callouts. We can do tick marks on all home runs. What that'll do is it'll take this number 10 and it'll just give us tick marks instead. So all callouts, home runs, regardless of size, get tick marks, and then you probably on your panel schedules want to turn your wire sizes on so that that's documented somewhere. Tick marks for number 12, and tick marks and the wire callouts if it's greater than number 12. So that'll take something like this, include the tick marks and that full wire callout, since it's larger than number 12. So that's if you really like the tick marks for the visual representation of the wire counting, but you also want to document the specific sizes. Next choice is we can have tick marks for number 12 single pole wires, and then wire callouts for all others. So what this will do is for a single pole number 12, it's going to do tick marks like here. So on this piece of equipment, single pole equipment, we'll do the tick marks. But this piece of equipment, since it's 3-pole, will actually get a full wire callout, even though it's number 12. then we have the option to just display the wire callouts for all home runs. No tick marks at all, just show me the wire callout. And then you take something like this, and it will get a wire callout. It is worth noting that we do not do full wire callouts on combined home runs. So even if you have this set, when you do a combined home run here, you actually, let's see, we end up doing nothing on that. If you have tick marks turned on, it would show the tick marks for the wires on that. And we might list a size. If it's not greater than 12, we'll list a size. So just be aware that combined home runs are treated a little bit differently by the software. So just be aware that we do that just because of the calculations and whatnot that are going on. We don't have a full wire call out once we do the combination. We can turn off the wire callouts and tick marks. So that will just display nothing. You'll just get the home run and the circuit it's going to, but no other labeling for the wires. So again, you'd want to have that documented on your panel schedule or somewhere else. And I believe the final option, yes, is nothing for number 12 wire, and then wire callouts if it's greater than number 12. So here, if we draw a home run with the number 12 wire, it again shows nothing. But if we update this number 10, it leaves the number 10 on there as opposed to taking it off. So those are all the options that we have for display of wire sizes on home runs. And for that one, you might again ask, why do we have so many options? And the answer to that is people ask for different options. Different people have different projects that we're working on, different standards that they like to use, and we do our best to support your standards as much as we can. So we've implemented those at the request of customers. Next option is whether to display the tick marks on loops or not. This is set to yes, so we draw the loops, tick marks on the loops. If we change it to no, it will not show them. And you'll see that there's no tick marks being shown. If they're shown on the home run, they will still show up on the home run, just not on the loops. So let's change our home run setting back to tick marks for number 12. Draw that one more time. Get the tick marks there, not on the loop. It keeps the drawing a little bit cleaner, so it's not as much cluttered. It's also kind of a throwback to when you were drawing the loops manually. It's kind of tedious to keep track of all those loops, so the standard that a lot of people had when they're drafting by hand is to not show tick marks because it's a pain to keep track of. With our software, we add them automatically, so it's not any extra work to show them. It does make the drawing slightly more cluttered, so there is that consideration. But you can be confident that the software is getting them in there and keeping them up to date without any work on your part, so you can show them if you'd like to have that additional information. We have the choice for the number of arrowheads on combined home runs. Some people like to show multiple arrowheads. If we do that and draw a home run, we'll actually get 3 arrowheads saying this is 3 circuits connected together. Then we have the option to share neutrals on combined home runs. That is currently off. This option actually shows up in another place where we reference this. We don't reference it here. But probably 10 years ago at this point, the NEC updated the rules for combined home runs, saying that if you combine a neutral in a home run, you actually have to have a shared trip. So that if one of those circuits trip, they all trip. So that if there's any load on that neutral, it's not. You just have to shut them all off. So setting this to yes is kind of for old historical projects, because you really shouldn't at this point ever set this to yes. We have it there largely for historical purposes. It should be no. If you actually want to share your neutral, what you want to do is combine them in the circuiting dialog. So let's take 7, 9, 11, and let's change this from a single pole breaker to a 3-pole breaker. What that'll do is it'll take those devices, leave them on the poles they're on, but now I have a 3-pole breaker, we have a shared trip, and we can draw the home run. They're all on the same breaker, so it's going to pick them all up, and then we get the nice shared neutral. That does require a 3-pole breaker. If you have 3 single-pole breakers, you can, in theory, put a breaker tie in there. So that would be a case where you'd want to turn that on. Then you'd have to document that, we have a breaker tie here, and then it would give you the shared neutral. So you can do that. It requires a little bit of manual work. With our software, you could combine them to a single 3-pole breaker. And if you ever need to connect to it, we have the circuit devices, which is what you typically use. If you want to, you can also use circuit to phase. And you can say, okay, now I can choose the specific phase to add devices to. So I can say, okay, phase C, circuit 11, I want to add these devices here. So we could add those to circuit 11 on this 3-pole breaker. So that's how you choose the phase if you have 3-pole breakers like that. That's used commonly for combining neutrals like that. And then also, if you have site lighting, you often have 2-pole site lights, and you want to put them on a 3-pole breaker and kind of rotate the phase that they're on. That's how you handle that. We have the blocks that are used for a couple different things. First is the circuit break block, and we've got the block listed there. This is the block that shows up when you break a circuit. So we have our break command, and that's this block here. So if you want a different looking symbol, you can create a new symbol and assign it to that block. Same thing for the home run block. You can change the block that's used, and then you can adjust the length. So if you don't want to use this block, you can adjust that. I'll take just a moment and see if I can adjust that to something interesting. If you don't want to show breaks, you can just set this to nothing. And actually, there's a none option. And then if we break a home run, we don't include a block. And then for the home run block, so we'll take their closed block and we'll use that. I'm not sure if the arrowhead length is right. That is based upon how the block is constructed. We'll leave it like that and see what comes up. We redraw our home run, and it puts in the different block for us. And so if you want to adjust the length of that block, you can adjust that scale factor. So let's do that as our final option here. Change the home run arrow length to 0.25, double it, redraw the home run, and now you have a longer arrowhead. So that's how you can adjust the arrowhead length if you're not happy with what we've provided by default. So those are all of the options available in Design Master Electrical under the home run and loops options. If you have any questions on those, go ahead and ask them, or any other questions related to Design Master Electrical. So the question is, there's an option to specify center point for loop. How is this used? That is under circuit options here, or set looping options. So we have this command, which actually has a bunch of the options that we were just looking at. It's a different place to set all of them. So here's that shared neutrals, where we say it's a 2008 NEC. So it's 11 years ago that this was changed. So you want to leave that as no. But there's a couple options here that are not in the options that you can control how your looping ends up on the drawing. And that's the select loop center point. And as long as we're looking at it, we can look at select preferred circuiting direction. So this is currently set to no, and so it's not being used. If I set it to yes, we can take a look at what it will do. It's going to ask us for a point, and it's going to kind of shift loops away from there. So I'll set that to yes, click OK. And you can see these loops are arcing kind of to the left. If we select a point here, they're going to all arc away from this point. So these ones will continue to arc to the left, and these ones will arc to the right. So if I draw my home run, there's the option to select another device for a combined home run. We'll press enter to go through that. Then you get another option, which is the arc center point. So you can press enter to ignore it, or you can specify a point. And actually, you'll notice nothing happened. And part of the reason for that is that once loops are on the drawing, we don't do anything with them. Because we've found that if we touch the loops that are there, people get irritated with us. So the loops are here, our software is not going to do anything with them. So this really only has an impact when you're putting them in for the first time. So I'll just go ahead and manually erase our loops here. All right, so now we'll run the draw home run command again. So if I don't select the center point, that's what it gives us. I can run the undo command to get back to where I was and remember to press my buttons right. So I'm going to run the draw home run command, select the device, no other devices for the combined home run. Now I select a point here in the middle, and it's going to have everything radiate away from that. So whereas these were previously looping to the left, and this one actually was looping down, they're all looping away from this point. So you just see that again. If I run the draw home run command, I'm going to select a point up here, and now this one, instead of arcing up, is going to actually arc down. So if you're not happy with the way it's drawing the arcing, that's what that option is for. The other option right next to it is the select preferred circuit direction. This will control whether we basically make the connections vertically or horizontally between these light fixtures. So right now, when I draw the home run, I'm going to ignore the preferred circuit direction. I'm going to ignore my arc point. It kind of goes vertically and then horizontally because I think these devices are a little bit closer in the y-axis than in the x. But if we wanted to have them go across first, we can use that circuiting direction. So I'll actually have it go left to right. And so now it says, okay, I'm going to prefer to look for things that are horizontally in the x direction rather than vertically. So it'll do all these connections left to right and then loop them all together. You can actually do some more nonsensical things. You can say, okay, I actually want to prefer this diagonal angle. So I want to have my light fixtures connect diagonally first. And then you get something goofy like that. I do it a more 45-degree angle, I think we'll get. There we go. So you can tell it, give it a little bit of preference as to how to make the connections or what those are for. What that command is for, and then the other one, the set center point, is for controlling the arcing. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.